Good afternoon, ladies and gentlemen. Today is the very first video of the algebra class, and today what we're trying to learn about is classifying and identifying numbers. So that's what my learning target is at the top here. It says I can identify and classify numbers. So basically, what you think about is every number you've ever known is called a real number, and sometimes we use a fancy R like that to illustrate the real numbers. This is every single number you can possibly think about. That's all numbers that are out there. Think of this as if this were the real numbers would be like the universe, right? Like the galaxy, something like that. Then it splits over into two family trees. Your family tree splits. One goes into what's called irrational numbers, and then one that's called rational numbers, and then there's more little tree stems from there. So let's talk about the irrational numbers. The irrational numbers, those are the things that you cannot write as a decimal. So the fancy letters that they use here is they use a fancy I. Now, my favorite irrational number is pi. You think of pi as 3.14, but it never ends. Another irrational number is something like radical 2. If you punch radical 2 in your calculator, you'll get all kinds of goofy decimals. Square root of 2 is just the square root of 2. So is like a goofy one like negative square root of 101. Those are irrational numbers, numbers that cannot be written as a decimal. Do not get this twisted with the repeating decimal, like 3.3333 repeating is technically 3 and 1/3. But these are non-repeating numbers, okay? So when it branches over to the other one, there's a bigger one called rational numbers. Rational is like the word ratio, which means fraction. So we use Q because Q is associated with quotient, which is associated with fraction. So here we go. How about the number 1/3? Yep, that's a fraction. Oh my goodness, negative 0.67. That is also a rational number. The number square root of 16, although in your mind you're like, oh, I know that. That's 4. Well, you can write it as a fraction. You can write it as 4 over 1. You can write it as 16 over 4. That's it. That's the rational numbers. This is you get introduced to rational numbers probably around grade number 3 or 4 where you're like, oh, geez, fractions. Now there's a little smaller group. That smaller group is called the integers, and we're going to use the fancy letter Z to signify integers. What are integers? Integers are straight up positive whole numbers, negative whole numbers, and their hero 0. So I'm going to go dot, 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 which means it goes on forever, but like negative 2, negative 1, 0, 1, 2, dot, dot, dot. That is basically what it means. So you're like, huh, that's easy. Integers were awesome. But you know what that was probably like second grade. First grade, maybe you dealt with whole numbers. Now we're going to use the letter W to signify whole numbers. All whole numbers are 0, 1, 2, 3, dot, dot, dot. They're basically integers without their cousins that are negative. Then the ones that they use a lot when you're a little kid, like watching like I don't know PBS or Noggin. These are what's called the natural numbers. Natural numbers are just regular old counting numbers. 1, 2, 3, 4. So it's basically integers, but not 0 or negative. So you see that's why this is a family tree and it's forked to smaller brackets. So basically, what are we going to use this for? You're going to use this to try to figure out, hey, what type of numbers does each one of these belong? So here's a little tip. Every one of these, 1 through 12, are all real numbers. Okay? But then it goes a little smaller. So where would you classify 30? 30 could also be a whole number. It could also be an integer. It can also be a rational number, and it's also a natural number. So realistically, you think about where it goes, like what all of them. This is as many as it can be. Like number 4, the square root of 21. I don't know what that is in my head, but I know that definitely it's a real number, and square root of 21 is something like a irrational number right there. Okay, so another one like number 12, radical 17 over radical 17. Well, that's a real number. That's actually 1. So that's going to be natural numbers. That's going to be Q. That's going to be Z, N, and it's going to be W as well. Okay. So I did 3 of them. You can go ahead and if you wanted to, you could pause this video and you could do the other ones. So why don't you go ahead and do that? Why don't you pause the video and then I'll see you back here in about a minute or two and we'll talk about uh, more real numbers. All right, welcome back. Now we're going to be looking at exactly, I guess, we're going to probably do something like this in class, but you can see this is a Venn diagram. I don't know if it's been a minute since you've seen a Venn diagram, but you can see that if this whole thing right here were the real numbers, that's everybody we know. Then you can see that every single, like real numbers get split into irrational numbers. So looking at this A through J, some of the irrational numbers I can see, that would be pi. So I'm going to put D here. And I'm going to put the letter G as well, right? But you can see in this Venn diagram, rational numbers, all natural numbers are rational numbers. They're a smaller version of that. So if I'm looking at my list, looking at this, I would say like, yeah, I could put 7 right here, right? That's totally cool. But actually, the very best one it fits is here. So it's still in the big circle, it's just in the smaller one. Then if I look at whole numbers, that's going to be like the letter H right there. 0 is a whole number. Sure, 0 is an integer and 0 is a rational. It's still in that circle, but that's the one that best fits it. Integers are positive and negative whole numbers. So for that one, I'm going to say D, H, and J. Well, wait a minute. That's negative 0.777, but that's like that's also an integer you can write it as. Rational, you got A, E, F, and I. A, E, F, and I. That's the other ones. So going through some of these, 1, 2, 3, 4, 5, 6, 7, and 8, which expression does not name an integer? Now, when I hear integer, I think of a whole number, positive and negative. So I know that this is an integer, and I know this is an integer. 12 over 6, wait a minute, that's 2. Looks like I found my culprit. It is B. Which one, which expression represents an irrational number? Which one of these represents an irrational number? Well, this has square root of 3 minus square root of 3, although that one is what I would go with. That would be 0, so that's an integer. So it looks like this one's going to be B, radical 75. Which one is not a whole number? 18 over 3 is a fraction, but that becomes 6. Whole numbers are positive, so by default, B, negative 10, is not a whole number. Number 4, which of the following is a true statement? Negative 9 is a whole number. Well, that one's a false one, so I'm going to cross that out. 0 is a natural number. Natural is counting, and 0 didn't come about till the Mayans invented it. Square root of 25 is irrational. I see that radical, but the fact that square root of 25 is 5, that one's gone. So by default, boom, D is the correct one there. Which of the following statements is false? All real numbers are rational numbers. All natural numbers are integers. Every integer is a rational number. And every whole number is a real number. Wow, that's a lot of words. Let's see here. False statement. Every whole number is a real number. Whole, real. Yep, that's good. So I'm crossing that one out. That one's true. All natural numbers are integers. Naturals are inside that big circle of integers. That one's true. Every integer is a rational number. Here's the integer. It is in the circle of the rational. So that's also true. So this guy is the false statement. All right. Now, give a number. Give an example of a number that's a whole number but not a natural. Oh my goodness, your hero, 0. Give an example of a real number that is not rational. Well, geez, you could do anything, but my favorite's pi. Give an example of a rational number that is not an integer. 5.1. That's a fraction. That's a decimal. It is definitely not a whole number. So that's it. You've done it. You've come to the end of the video. So hopefully you've taken notes, and I look forward to seeing you in class, and may the force be with you.